Hi everyone, today we're going to be taking notes on sections 9.1 to 9.3, and those sections include Intro to Statistics and two sections on measures of center. If at any point today you need to pause the video or rewind to try to better understand something, feel free to. Make sure you are dividing your paper from your interactive notebook into 3 sections, and those sections are going to give you the term. So for example, a word that we're defining. So in that first section, it will usually be the term, so the vocab word that we're defining. The second one will give us the definition. So what does that mean? And the third one will be an example, so a demonstration of how to solve or what that would look like. Okay, so divide your paper into those sections and we are going to get started. All right, so starting off with statistics, we want to know what statistics is. So what is statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting data. So for example, if I'm a teacher and I am giving out a quiz, I would give out that quiz and I would collect the data. With that data, I would go ahead and decide if the students understand what I taught, or maybe if there are a few sections I should go back and reteach, or maybe a common mistake people made so I can address that and move on in the future. So an example of statistics would be a teacher collecting quiz scores. There's a ton of other examples. For example, sports. A lot of times we'll collect data in sports, like what is your batting average? Or how many yards did you rush that game? Or how many goals did you score? What's the average number of goals you score a game? Those are all examples of statistics. We see statistics in everyday life. All right, so talking about statistics, we want to learn what a statistical question is. So a statistical question, kind of a tongue twister. You can call it a stat question if you want. But remember, we talked about this a little bit in class. It's a question in which you would expect a variety of answers. And sometimes when I take notes, I abbreviate a little bit. So I'm just going to put a Q for a question. A question in which you would expect a variety of answers. And I want to put variety in all caps because that's a really important part of this definition. So think about it. Statistical question. You're collecting statistics, right? You want to get a variety of answers, a lot of answers. All right. So what's an example of a question in which we can get a variety of answers? What about something like this? How many hours do 6th graders spend on their phones? Now, of course, when we ask this question as 6th graders, it's going to be a statistical question, right? The answers will vary. So if I asked Jessica, she might say that she spends 2 hours on her phone. And if I ask Carlos, he might say, well, I spend 0 hours on my phone because I don't have a phone. Or if I asked Deborah, she might spend 8 hours ever since she gets home all the way to the evening. She might be on her phone. So the answers might vary, or the answers would vary. That would give us a variety of answers. That is a statistical question. All right, now what would be the counter of that? Think about a statistical question where you're getting a variety of answers. What's the opposite of a variety? Only one, right? So a non-statistical question, statistical question is one in which you could expect only one answer. So a question in which you would expect only one answer. Only one answer. All right. All right, so it's like a fact, right? There would only be one answer to it. So for example, something like, how many stripes are on the American flag? There's just one answer to that question, right? That means it's a non-statistical question. All right, so that's an example of a non-statistical question. Anything that's a fact. So if you said, how many states are in the United States? Or how many pencils are in this pencil case? Different things that there's a fact, there's just one answer to them. That would be an example of a non-statistical question. All right? Now let's move on to a visual representation of data called a dot plot. So basically, if you ask someone a statistical question, you collected data from them, you can make that into a visual representation. And one of those is called a dot plot. So that's a visual representation of data. And that's when each dot represents a piece of data, where each dot represents one piece of data. All right. So in a few minutes, we will go ahead and do an example with the dot plot, but I'm just going to draw a quick one of what it looks like real quick. So you'd always have a scale. That scale would always be even. So for example, that scale would go in order. So let's say from 0 to 3 in this case, and it would have some dots. So let's say it looked like this, like that, okay? And let's say that represented hours of homework. All right? Then according to that dot plot, we can say most of the students surveyed here spent 2 hours on their homework, and one of the students spent 0. No students spent 1 hour. That's an example of how to read that dot plot. So that's just a quick example of what a dot plot could look like. All right, always an even scale, and we put dots to represent pieces of data. All right, so within a dot plot, we can label different parts, and those can give us meanings of what something means. So one of those is a peak. And just like it sounds like, the peak is a point on a dot plot that has the most data. That has the most data. And I'm going to say it's the highest point, like a mountain peak. That's an easy way to remember it. And remember, I abbreviate sometimes just to make less writing for myself and you guys. So that's the highest point, like a mountain peak. So if I'm referencing this example specifically, right here, that is my peak because it has the most data. All right, so I'm abbreviating a little bit, BC for because. That's the peak because it has the most data. See how most people spent 2 hours doing homework on that. All right, that's the peak. So a peak is any point where it's the most, and a peak can occur more than once. You can have 2 peaks. Like if 3 and 2 both had 3 points, those would both be the peaks. You could have more than one. So I should write that. You can have more than one. All right? right, what is another part of a dot plot that we can label? That is a gap. Oops, I'm on the next page, so it's not really showing. Let's erase that so you guys can see it a little better. And a gap, oops, I should just move down, making these a little neater. And a gap is going to be an area on a dot plot where there's no data. An area on a dot plot where there is no data. So kind of like a gap in your teeth, right? That would be a space where there's nothing, right? Same thing. So on a dot plot, you should be able to see a physical gap because there's no data there. So when I'm looking up here, at this point, I notice a gap right here. See how there's a portion where there's no data at all? So that would be where 1 is on that dot plot. So blank space. And same thing, you can have more than one. You can have multiple gaps. All right, so we have a visual example of what that looks like. All right, what else? We have a cluster. And a cluster is going to be an area on a dot plot where data is grouped together. An area on a dot plot where data is grouped, and I'm going to say in a small space. So we see the majority of data in one little pocket of space. Let's look at our dot plot and see if we see a cluster there. I would say in that case, you can kind of argue that a cluster would be where 2 and 3 are together. You can say the majority of the data is 2 and 3 there. That might be a little bit of a stretch, but anywhere where data is grouped together, and same thing, you can have more than one. So we can say grouped together, and once again, you can have more than one. All right, so those are some ways, more than, oops, what am I writing? More than one. Those are some ways that we can describe different points on our data, on our dot plot. All right. Now maybe at the end, if we have time, we can create another example for dot plots. All right. Now we're moving on to some other sections talking about measures of center. So this would be 9.1, 9.2, and 9.3 in case you had to reference it in your book. And we're going to talk about measures of center. This is a really big topic in statistics. So measures of center, and that's a summary measure that describes a full set of data using one number. So that is a summary measure that describes a full set of data using one number. So through that one number, it can kind of tell us something about the data. All right, an example of measure of center, these are 3 really big topics for us. Our mean, median, and mode. Those are our 3 measures of center. And we'll be talking about those right now and giving you an example of what those are. But each of those tell us something about the data set. So think about measures of center. They should always fall somewhere within our data set, okay? So let's talk about mean to start. Mean. All right, so a mean, if you've ever heard that before, the mean is the average. And how do we find that? That is found by first adding all the pieces of data. So you first add, I'm going to put that in caps so you know, all of the data points. Then dividing by how many there are. So dividing by the number, that's a number, not a hashtag, of values. Values means numbers in, in the set. All right, so what is a mean? Well, a mean is the average. And how do we find that? We find that by first adding all the values and then dividing by the numbers in the set. Now, what would help us out a little bit is probably seeing an example, right? So let me give you one. Let's take this data set. I'm going to make one up. Let's say 4, 2, 7, 8, and 5. Let's make that our data set. All right, so we're going to find the mean. So what am I going to do? I am going to first add them all together. So 4 plus 2 plus 7 plus 8 plus 5. And I'm going to see what that equals. All right, so you can use your calculator, you can use your head, whatever you want. 4 plus 2 would be 6. 6 plus 7 would be 13. 13 plus 8 would be 21. 21 plus 5 would be 26. So first we have to add that. Then once we add that, we can divide it. Remember that little fraction symbol is the same as dividing. We're going to divide it by how many numbers are in the set. So I'm going to count them up. 1, 2, 3, 4, 5. There's 5 numbers in that set. So now I'm going to do 26 divided by 5. And this is when you can absolutely use a calculator, guys. All right, as long as you're showing all of the steps. So see how I just showed all of that? You could have definitely done both parts on your calculator, but I want you to show it. And when I'm doing that on my calculator, 26 divided by 5, I get 5.2. All right, and my measure of center should fall somewhere within this set. So notice how 2 is the lowest and 8 is the highest. Is 5.2 in between 2 and 8? Yes, it is. So I can be confident I didn't make a mistake because remember, your measure of center should fall somewhere within your set. If you ever get a measure of center that's smaller than the smallest number or bigger than the biggest number, you know you made a mistake somewhere because it's a measure of center. It needs to fall somewhere within your set. Okay? All right, we'll do a lot of examples in class, but here's a little intro with an example to mean. And remember, mean is the average. A way I remember that is I say it would be mean if someone called you average. And why is that? Because you guys are all above average. You are superstars. So that's how I remember it. If that helps you, then you can write that down. If that doesn't help you, you don't have to. But I say it would be mean if someone called me average because with the mean, median, mode, they're all M's. They're easy to get switched up. All right? Moving on. Moving on to the next one, which is median. Mean and median. Median is another measure of center, and it actually is the middle value. So that's the middle value of the set. I'm going to write middle in all caps since that's the important part. It's the middle value in the data set. And how do we find that? That one is found by, this is really important. First, we have to order the set. This is the most common mistake with median. You have to first order the data set and then find the middle value. So it has to be the value directly in the middle. Now, if you have an even number in your data set, there's going to be 2 in the middle, but we never have 2 medians. So if you have an even number of values, oops, what is happening? Sorry, technical difficulties. If you have an even number of values in your set, you're going to find the 2 middle. Find the 2 middle values and find their mean. So you can you can use mean again. Find their mean or their average. All right, and I will demo both of those for you, okay? So the middle value in a data set, we first always have to order. So I'm going to use that same example I used right above with those numbers. I'm going to take those same numbers. So we are going to use 4, 2, 7, 8, and 5. So remember, first we have to put them in order. So what would go first? 2 would. 2, then 4, then 5, then 7, then 8. All right, now that these are in order, all I have to do is simply find the middle. If there's an odd number of values in their set, there'll be one directly in the middle. If there's even, then we need to find the average of the two middle values. So I'm going to show you. You can just count off from each side. You can go 1, 1, 2, 2 until you find the one directly in the middle. So in this case, the median is going to be 5. See how easy that is? But let me give you another example. Let's say I added another 2 in that set. I want to show you how it would change if there was an even number in the set. So let's say I'm going to have the same numbers, 4, 2, 7, 8, 5, but I'm going to add another 2. So now, once again, we still have to start by ordering them. So I'm going to go 2, 2, 4, 5, 7, 8. And if you had this on paper, if it was me, I'd be crossing them off as I go to make sure I don't make a silly mistake and forget one. All right, so now I could do the same thing. I could X them off on both sides. 1, 1, 2, 2. And see how I'm left with 2 in the middle right here? Well, my median would be the number that's in between 4 and 5. All right, so what do I have to do? I have to find the mean. I have to find the average of those numbers to find out what's in between. So how do we find the mean? If you reference back up on your notes, you are going to add the values in the set. Remember, in this case, we're only talking about those two middle values. So you're not adding the values in the whole set. You're just adding 4 and 5. So for median, when you're finding the mean of the two middle values, you should only be adding 2 values since it's just the two middle ones. So 4 plus 5 is 9. And how many values are in the set? Well, we're just talking about those 2 values. So there's 2. We do 9 divided by 2. And if you did that on your calculator, that would get you 4.5. So the median here would be 4.5 if we were talking about that extra value added in the set. Okay? Hopefully that makes sense to you. Like I said, we're going to have a ton of practice in class working on those things. All right, let's keep moving. We are going to go to mode. Oh, I'm going to give you one more way to remember median. So median sounds like medium. Sounds like medium. And that's not a small, not a large, but a medium, right? Right in the middle. Sounds like medium, right in the middle. And once again, you don't have to write that, but that's a way I remember it. It's right in the middle, not a small, not a large, but a medium. And that a lot of times will help you. Once again, they're all M's, so it's easy to confuse them. Last M, mode. And the mode is the value in a data set that occurs the most frequently or the most often. All right, so let me use that same data set as an example, the one I just used. So we did 4, 2, 7, 8, 5. Okay, I'm going to start off with that original one. In this case, there is no mode because they all occur the same amount, right? They only occur once. So in that case, there is no mode. Now I'm going to use the one when we added that 2. There would be 4, 2, 7, 8, 5, 2. Now do you see how 2 occurs the most because there's 2 2's, but there's only one of everything else? So in that case, the mode would be 2. Now we can always have more than one mode. So for example, if it was 4, 4, 2, 2, 7, 8, the mode would be both 4 and 2. But mode does not always mean occurring more than once necessarily. It could be So for example, let me give you one more. Let's say we had 2, 2, 5, 5, 8, 8, 8. In this case, the mode would be 8 because 8 occurs 3 times, but everything else occurs twice. So a lot of times people get confused and they think mode just means happening more than once. Not necessarily. It's just the one that happens the most in a set, and there could be more than one. All right? So that is mode. And I always say that sounds like most, and it's the one that occurs the most. Remember, not the highest value, not the number that's the most, but the number that occurs the most. So you're seeing it repetitively. Okay? All right, those are really big topics. Let's keep moving on. How about this? We have range. And range is the difference between the greatest and the least number in your data set. The greatest, that means biggest. And least, that means smallest. Values in a data set. All right, so for example, let's say we'll use that same data set. Let's use that same data set again. We have 4, 2, 7, 8, 5. All right, so you're going to find your biggest value. I'm going to say max minus min. Your maximum, your biggest value, minus your minimum, your smallest value. So my maximum value, it looks like, is going to be 8. And my minimum, my smallest value, is going to be 2. So my range is 8 minus 2. That would be 6. So basically that means there's a difference between 6 in my data set. All right, that is my range. Really straightforward and easy. Almost at the end, guys. We are at outlier. And an outlier in a data set is a data value that is much greater or much less than all the other values. Not all sets have an outlier. That is much greater or much less than the rest of the data. I'm going to say all of the other values. Remember, values means numbers. So let me give you an example, because that previous example didn't have an outlier, but let me add one. What if it was 4, 2, 7, 7, 8, 5, and 27? See how 27 would be much bigger than all the other values? That would be an outlier, okay? So if it's much bigger or much smaller than all the other values, that is an outlier, okay? So that would be an outlier. And like I said, not all data sets have an outlier. Like if you looked at this previous one, there would be no outlier because they're all pretty close together. All right,